Hello and welcome. In this video, we are going to discuss the topic uh, that is shown on your screen, preprocessor. So, what preprocessor is? Preprocessor is basically a program that runs before the compiler. It takes source code as an input, makes some changes in it, and produces the expanded source code as an output. That expanded source code is passed on to the compiler for compilation. So this preprocessor is basically invoked by preprocessor directive. So all the preprocessor directives, preprocessor directive is basically a special type of command that starts with hash symbol. So this in every program generally we use this hash include stdio.h. So hash include is a preprocessor directive. It's a command that is given to the preprocessor to do something. So every preprocessor directive must start on its own line. If you want to extend a preprocessor directive line to multiple physical lines, you can do that by putting the slash at the end of the line. For example, on this slide we have shown I have shown over here I have divided the hash include stdio dot and into 3 lines. So in one line I have written hash include, so to instruct the preprocessor that this line is basically not the end of the statement, so you will put the continuation symbol backslash. So this backslash will instruct the preprocessor that the next line is also the part of the same statement. So you can write it like this also, as shown over here. I have divided hash include stdio in 3 lines. So this is equivalent to hash include stdio if you write that in single line. Another preprocessor directive I have shown over here, hash define. We will discuss it in more detail. So many preprocessor directives are there that we are going to discuss in the coming slides. So one more important point, the preprocessor directive, if you write, generally we don't put semicolon at the end of the preprocessor directive. For example, over here in this slide I have shown that there is no semicolon at the end of hash define. There is no semicolon at the end of hash include, although you can put semicolon at the end of these lines. But what will happen if you put semicolon, that we will discuss in the coming slides as well. So these preprocessor directives are basically, these are divided into 2 categories. One is unconditional, other one is conditional directives. We'll discuss these 2 kinds in the coming slides in more detail. Or you can divide the preprocessor directive broadly into 4 types. Those 4 types are shown are here. Micro substitution directives. And the second one is file inclusion directive. Third type is compiler control directive, and miscellaneous or other directives. So first we are going to discuss the micro substitution directive. So in this case, how you define a macro, that we are going to discuss. So to define a macro, we start the macro definition with hash define. So as shown in this slide, hash define is the macro substitution directive. Then we use an identifier, and after that we use the definition of the identifier. So we have defined 2 identifiers over here. One is string1, other is str1, other is str2. So the definition of the str1 is void, and the definition of the str2 is main. So this is our source code, right? Please note that instead of writing here void main, I have written str1. So the value of str1 is void, and str2, the value of str2 is the main. So when you will run this program, the preprocessor will be called, and what the preprocessor will does, as I have given you the definition before, preprocessor basically takes source code as an input. So this code that is there on this slide will be passed on to the preprocessor as input. So Then the definition part says that the preprocessor makes some changes on the source code. So what kind of source changes the preprocessor makes in the source code, that we are going to discuss now. So when you will run this program, every occurrence of str1 will be replaced by void. So this str1, it will be replaced by void by the preprocessor. Then every occurrence of str2 will be replaced by main. So the preprocessor will change this to void and main. So this will become your usual program heading, void main, right? And then this expanded source code, so after replacing str1 and str2 with their definition, that expanded source code will be passed on to the compiler will compile it, run it, and will give you this message hello on the screen, right? So I repeat, when you define the macro, you have to write first hash define, then identifier, and then its definition. We'll discuss more examples about define in the coming slides as well. So the next example is based on hash define. So here we are going to discuss a program. In this program, we are finding the area and circumference of the circle. The logic of the program is very much clear to you. So again, in this program, we have used hash define to define pi. So the value, this is the symbolic name that we want to define, pi. It can be capital or in lowercase letters. Then its definition, the value of pi 3.114. And again note, we have not written semicolon at the end of this line. So later on in this slide I will discuss with you, if we put semicolon at the end of this line, what will happen. So this is hash defined, and in the program we have used pi twice. One is in the expression to find the area of the circle, and other in this line to find the circumference of the circle. So this is the program, and when you will compile it, run it, what will happen, as we discussed earlier, first of all the preprocessor is invoked, and the preprocessor will replace every occurrence of pi with its value. So when the preprocessor will run, it will replace this pi with its value. So this line will change to area is equal to 3.14 into r, and then over here this line will be, in this line pi will be replaced by its value. So this line will change to circumference is equal to 2 into 3.14 into r. So after replacing every occurrence of pi with its definition or with its value, then the program will be passed on to the preprocessor compiler for the compilation and later on for execution. So then if you run this program, you are going to get these two outputs. Now let's discuss what will happen if we put the semicolon at the end of this hash define. If I put semicolon here, as I have shown in the comment here, and you keep the program, rest of the program same, then what will happen when it will substitute the value pi over here, this line will become area is equal to 3.14 semicolon, right? So it will put the semicolon at the end of the value as well, because this semicolon is now the part of the pi definition. So this line will change to this, and if you look at it carefully, this is basically syntactically it is wrong. Area is equal to 3.14, this is one line, and rest of the part star into r into star, this is a line that is generated by the preprocessor after the substitution. So here you will get the error message. So how we can overcome these kinds of error? The solution is, if you are using a named constant or symbolic names that you have defined with the pi, you use that at the end of the expression. So instead of writing area is equal to pi into r, if you write this line as area is equal to r into pi, then when the preprocessor will make changes over here, when it will replace pi with its definition, this line will change to this line. So now this line is syntactically correct, although there are two semicolons at the end. So but the two semicolons will not make any difference, right? So this is syntactically correct. So in this case here, if you put the semicolon at the end of the hash define, the statement like this will run perfectly. And please note again, this line you have to change as well, because here the pi is in between the expression, so you have to shift this pi at the end, and this circumference expression will change to 2 into r into pi. So if you change it to 2 into r into pi, and this expression to r into pi, and you write the define line hash define pi 3.14 semicolon, then it will run perfectly fine, right? So you have to look into the expression whether after expanding the expression, that expression is syntactically correct or not. If that is syntactically correct, that means that that program, that statement will run perfectly fine. If after the substitution of the value of that symbolic name, the statement that is generated is not syntactically correct, then it will not run. So we'll discuss this concept in the coming slides in more detail. So next is the use of the backslash, and as we discussed, this is used to extend the preprocessor directive to multiple lines. So here we have used the macro just like a function. So this is a function like macro. So this is the name of the macro. Print. This macro is parameterized. There are two parameters, x and y. Then we are putting the backslash to instruct the C preprocessor that this preprocessor directive spans multiple lines. So it spans across two lines. So this is the definition part of the macro printf. So what will happen when you will run this program? This we are invoking the macro over here in the main. So when a preprocessor runs, what it does actually, wherever you have used the macro in the main in the program, that will be replaced by its definition. So this print will be replaced by its definition. The definition is printf hash x. So this Nitin is basically will be passed to the x, that means x is Nitin. So this hash x, basically what it does, it will convert whatever is the parameter to string. So this Nitin will be converted to string. So this is basically hash x is Nitin in double quotes. So this is what you will get. So the important point here is the hash, whenever you use it with the symbolic name, it will convert its value into string. So this will get converted into string. Then there is an and, this is also in double quotes. So this here we have Nitin in double quotes, then with a space we have and in double quotes, and then hash y, because in y we have Ashok, so hash will convert that value Ashok into a string literal, that is Ashok in double quotes. So this means this printf statement will have multiple strings separated by spaces. So if you pass a printf statement multiple strings separated by spaces, printf statement concatenate all those strings that you pass to it. So after concatenating all these strings, what you will get? Nitin and Ashok from CHITKARA University. So this string will appear here because this print will be replaced by this line. So when you will run it, you are going to get this output, Nitin and Ashok from CHITKARA University. The next slide is another example that is based on macro. So again we have a macro, we have given it a name sqr. This is basically used to find the square of a number. We are passing it a parameter x, and its definition is x into x. So when you will call this macro through this line in the main square of a, we are calling it just like a function. So these kind of macros are called function like macro or augmented macros. So as we discussed earlier, when the preprocessor will be called, it will replace the call with its definition. So this is the macro call. We are calling it with a. So this line sqra will be replaced by x into x because we are passing a. So this means that this definition becomes a into a. So preprocessor will make a change in this printf statement. So instead of square of a, it will replace it with a into a, right? So value of a is 5, so 5 into 5 25, so you will get the result 25. Fine. I have added one more line after that. So what will happen in this case if you are calling sqr with 2 plus 3? So here 2 plus 3 is basically x. So what the preprocessor will do, it will replace every x with 2 plus 3. So this square of 2 plus 3 will change to 2 plus 3, this first x, then into is there, and this second x will be replaced by 2 plus 3. So what you are going to get is 3 into 2, 6 plus 5, 11. So we expected that we will get the output 25, but this line is giving us the result 11. So how we can correct this? For this, the solution is, instead of writing the parameters in the definition part, you put those parameters in parentheses. So if you put these in the definition part, if you put parameter x in parentheses, now see what you will get. In this case, this 2 plus 3 is the value of x, so it will get replaced by x into x, that is also in parenthesis. So this is 2 plus 3 into 2 plus 3, so this will value to 5 plus into 5, so you will get 25. So again, if you replace it with x in parenthesis into x, you will get 25 as the result. If you don't put this x in parenthesis, you are going to get the wrong result. So the next example, again, it's based on the function like macro. So here we have named the macros max. Basically it will find the larger of two number. This is the definition part of the x. So intentionally I have included the parameters in parentheses. So if the x is greater than y, then it will return the value of x. Otherwise, it will return the value of y. You know about this, the conditional operator. So when you will run this program, as we discussed earlier, this is the macro call. It will get replaced by the definition. So this max 1020 will be replaced by the definition. So what will appear over here is this thing, 10 greater than 20, then 10 else 20, because this condition is false, 10 greater than 20. So it will return the else part 20. So this means the result of this entire expression will be 20, so that will get printed over here. So you will get the larger number is 20. So the main crux of the problem is, whenever the macro is called, it will replace the macro with its definition. The actual parameters are replaced by the dummy parameter, the parameter that you have used in the macro call. So the next is, if you define literals or named constant, symbolic constants, you can nest them. So in this example, we are discussing the nesting of the identifiers. In the first line, we have defined the identifier m, its value is 100. In the next line, we have defined one identifier n, and its definition is m plus 100. So we are using this named constant in the definition of the other named constant. So this is basically a nesting of the identifiers. So when you will run it, here it will replace this n with m plus 10. So this will become m plus 10, and every m will be replaced by 100. So this will become 100 plus 100 plus 10, so you will get 210. So you are going to get the result 210 of this. I think it's clear to you. Then comes some predefined macros. These predefined macros are basically starts with the 2 underscore and ends with 2 underscore. The very first is underscore underscore file underscore underscore, and when you use this in your program, it gives you the name of the current file, right? And then is if you use this predefined macro, it gives you the line number. Then this date gives you the date in this format. Time gives you the time in hours, minutes, and second. Similarly, stdc, when it expands, it gives 1 when the compiler conforms to ISO standard C. And this stdc version gives you the C standard version. So I have used all these in one example. So if you look at this, the output of this file gives you the string equivalent of the file. So because my file is main.c, I have named it this program as name main.c. So we are getting the first result main.c. The next date will give you the string output in the format that we discussed earlier. So it will give me this result March 23 and 2020. Similarly, time I am getting in the format hours, minutes, and second. This line is basically, this statement is the 7th line of this program, so you will get 7 over here. If you count from this, this is first line, second, third, fourth, fifth, sixth, seventh. So this is the 7th line of the program. That's why this line attribute is giving you the output 7. So rest of the outputs are clear to you. In case of any doubt, you can leave your doubts in the comment section. Then comes the file inclusive directives. So in case of file inclusive directive, we use hash include. We have used it a lot in C programs. So what we do, we use first hash include, then the name of the file whose contents you want to include in your program in less than greater than sign or in angle brackets. You can also use double quotes for the file inclusion. So what is the difference between these two? If you use the angle brackets, then only the standard directory that is set when you configure your C compiler, that is searched for the file. And if we use double quotes to include the file, then what the preprocessor does, it basically searches in the current directory, and if that file is not there in the current directory, then it searches in the standard directory that is set at the time of configuring your compiler. I'm going to explain it with the help of an example. So the basic aim of file inclusion is you can keep your program in 2 different files, right? So that is the main benefit of this. I have included here is the code to find the area of the circle. So to find the area of the circle, I have created 2 files. One of my file is area.h. I have saved it as area.h. So in this file, I have just one function definition, float area, and in the other file, I named it circle.c. This program is there. So now in this program, I want to use area. So how I can use area? I have to include this file in my program. So here I am including it, include hash include area.h. This area.h is name of the file which I want to include, right? So when you will run this program, what will happen? So when you use hash include, the contents of that file get pasted in at the place where you have used this directive. So that means this entire file contents, right? This entire contents of this file get pasted over here. So you will get these 6 lines over here. right? So this will become the one file after the preprocessor. This thing will get pasted over here, and your program after that we will call it the expanded source code as we discussed earlier, and then you will run it, and it will ask you the radius of the circle, and then it will find the area and will give you the result as per the format given in the printf statement. So you will get this output. So I repeat what this does basically. If you use include directive, the file that you write in the double quotes, that file contents get pasted over here. So that is the file inclusion directive purpose. So the next is the second type of preprocessor directive, compiler control directive. These are basically used for conditional compilation of the group of statements. Some of the compiler control directives are ifdef, ifndef, right? We are going to discuss these compiler control directives in the coming slides. The very first example on these compiler control directives is this. In this program, we have defined a named constant line, and we have given a value 0 as its definition. So when you will run this program, here we are using the preprocessor directive if. So it works as a normal if statement that you have used many times. So if then there is a statement line, because the value of line is 0. As we discussed, the preprocessor replaces the named constants with its value, with its definition. So this will become if 0, because if 0 is false, 0 is treated as false in C, so that means this condition is false. So in this case, the else part will be included. So only printf line 2 will become the part of the expanded source code. So in the expanded source code, we have just one line in the int main, and in it we have just line 2 that will be passed on to the compiler, and you will get line 2 as a result. So here the important part is, this is basically conditional compilation. We want to compile one part of the program. If the line has some value other than 0, then whatever you will write between if and else directive, that will get compiled. Rest of the else part and then else if whatever you have written between else and if will be skipped. And if the this condition is false, then the compiler will compile only the statements that you have written between else and if. So that's why it's called conditional compilation directives, because it compiles only a part of the program depending upon the outcome of the condition. So the next is the ifndef directive. So we have written over here ifndef is basically, it works, it evaluates to true if you have defined this symbolic constant line. We have defined it already, so this means this will evaluate to true if defined line. If I remove this line hash define line 0, and then this if will evaluate to false, because line is not defined already, and if you check if defined line, it will not be defined, so it will evaluate to false. So it depends whether you have defined the symbolic constant earlier or not. If you have defined it, then this will evaluate to true. If you have not defined it, then it evaluate to false, because we have defined it earlier. Line is defined earlier in the first line of the program, so this will evaluate to true, right? Although its value is 0, because we have defined it, so this will give you true. If it is true, that means the only the part between the if and the else directive will be compiled. So your main will have just one this line. Rest of the part will not be included in the expanded source code. so only one line will be there. So what you will get is line 1 as the output. So if I remove this line from the program, then ifndef line will evaluate to false. In that case, only the compiler will compile this line 2, and in that case you will get line 2 as the output. Then if can be used like this also. In this problem we are going to discuss if else if for multiple conditional checking. So here in this program we have defined one named constant mks, its value is 65. So in this part we have written many if as if statements. So first of all it will evaluate this if part, if mks, because the mks is 65, so preprocessor will replace this mks with its value 65. So 65 greater than 75 is false, so it will go to the else part. In the else if, it will evaluate the another condition, mks means 65. This will evaluate to true, and because this evaluate to true, that means that your expanded source program will have just one line in it, that is grade B, right? The rest of the part will not be there, so the compiler will compile just this line, the rest of the lines will not be compiled, and you will get this output grade B. So if the value of suppose mks is 10, so this will be replaced by 10, all the occurrences of mks, so this and this will be replaced by 10 if the mks value is 10. So in that case 10 greater than 75 equal to 78 is false. This will evaluate to false, so it will go to the else part. This will also evaluate to false, so it will go to the else part. This will also evaluate to false, so it will go to the else part. So here it will compile just this line grade B, and you will get grade B as the output. Please note the syntax. And in the case of the last statement here, where we are not checking any condition, we use else. If you want to test the condition, we use the else if. And then the if ends with the and if. So the next problem is on if not defined directive. So this directive evaluates to true if the symbolic constant is not defined. So in this program, if not defined m, because we have defined m already, so if not defined m will evaluate to false. If it evaluate to false, then it will go to the else part here, and you will get this output, because this line will get compiled and you will get already defined. If I remove this line from this code, this one, then if and if, because it is not defined, I have removed it, so this will evaluate to true. Then this line will define m and assign value 200 to it, and then you will get this output newly defined. And in the second problem that we have discussed over here, it's not defined and accordingly it will work. We have discussed it. Then there are some miscellaneous directives. One is undefined. This is used to undefine a predefined directive, and let's discuss it with this example. So in this case we have defined m, its value is 100. We have defined another named constant n, its value is m plus 10. So when it will go here, it will expand it, and here in this line we are undefining m. So once you have undefined a named constant, in the rest of the lines, if you use that will generate an error. So you are using it after that, so it will generate some error message. And if I write a line in between this undef and printf statement over here, hash define m 200, then it will work, because first you are undefining m, and then you are assigning a new value. So if I use one more line in between undef and n and want to assign different value to m, then it will work fine. So this is all about preprocessor directive. So we'll discuss about the pragma directive in the next lecture. So till then, happy learning.